All right, so in right here, what we want to do is we also want to factor. And the hardest part about factoring a difference of squares is just recognizing it's a difference of squares. Okay, so let's go through this one. Is 49 a perfect square? Is x squared a perfect square? So that makes the whole first term a perfect square because the number and the letters are perfect squares. Is 16 a perfect square? Do I have a minus sign? So this is a difference of squares that can be factored. Now let me ask you this right here. Okay, is there a number that will go into both of these? No, but if there was, we'd factor it out before we even checked it as a difference of squares. Okay, so since it is a difference of squares, we're going to write two what? Two binomials. And we'll take the square root of the first term. What is the square root of 49x squared? 7x. All right, 7x in both. What is the square root of 16? 4 and 4. And then I just write one of each sign, plus, minus. So that is the original problem factored completely. Remember what I said, the hardest part about factoring a difference of squares is simply recognizing that it is a difference of squares, because you're going to get a problem in a month that we're not talking about difference of squares, and you have to recognize, oh, that's a difference of squares, right? So let's look at it. Is the first term a perfect square? It is. Is the second term a perfect square? Is there a minus sign in the middle? So this is a difference of squares. So I'm going to write two binomials. What is the square root of 25x squared? 5 what? Yep, so I'll put it here and here. What is the square root of 16? 4 and then I just put minus plus or plus minus. This is the answer right here. Let's look at this problem. Now, when you look at it, at first glance, you might say, this is not a difference of squares because 20 is not a what? Perfect square. But remember, before you decide whether or not it's a difference of squares, you need to look at both terms and see, is there a number that can be factored out? Yeah, 5 goes into 20 and 5 goes into 45. So let's factor out 5. And when we factor something out, it's like we're dividing each term by it, right? So 20 divided by 5 is 4x squared minus 45 divided by 5 is 9. And now look what's inside the parentheses. Is 4x squared a perfect square? Yes. It is. Is 9 a perfect square? Yes. It is. Is there a minus in the middle? Yes. So look at my original problem. You can't just say, well, 20 is not a perfect square, so I can't do it. You got to see, will something factor out of both, right? And so now let's factor what's inside the parentheses. I've got 5 times, and I'm going to make 2 sets of what? And what's the square root of 4x squared? I'm going to put 2x here, and I'm going to put 2x here. And what's the square root of 9? I'll put a 3 there, and a 3 there, and then I'll go plus, minus. This right here is your original problem completely factored. So as I look at this problem, my first inclination would be to say, well, heck, 5 is not a perfect square, so I can't do it. But before I can decide that, I got to look at 125 and I got to look at 5 and I got to ask myself, is there a number that goes into both? What is it? 5. So let's factor out 5 from the 125 and from the 5. So I'm going to write 5 here. And then remember, factoring means you're dividing each term by what you factored out. What is 125 divided by 5? 25x squared. And what is 5 divided by 5? Yeah. Now, let's look at what we have remaining. Is 25x squared a perfect square? Yes. Is 1 a perfect square? It is, because the square root of 1 is not a decimal. And is there a minus sign in the middle? Okay, so you can factor this as a difference of squares. So I write 5, and then I'll put 2 sets of parentheses. And I'll take the square root of this, and I get 5x and 5x. And I'll take the square root of 1, and I get 1 and 1. And then what do I do to finish it up? Plus, minus, or you could have done minus, plus. So what you see right here is the answer completely factored.